All right, so 2.6, we are proving lines parallel. This is going to look a lot like 2.4 and 2.5, but we're going to just do the opposite of what we did in those first two sections. So in 2.5 specifically, we said if we have parallel lines, we create all these angle pairs that have a relationship. And now in this section, we're going to do the opposite. So we're going to say if these angles have a relationship, then these lines have to be parallel. So, for example, in this first one, if I'm looking at 2 and 6, I see that they have congruent marks, and those are corresponding angles. So I can say that L is parallel to M because corresponding angles are congruent. Right? If I look at this next one, I see 4 and 6 have congruent marks, and those are alternate interior angles. So again, I know that those are congruent, which means that the lines are parallel because alternate interior angles are congruent. I'm going to use some shorthand there. Remember that sign means congruent, this. Okay, if I look at this one, 3 and 6, but it's telling me that those two together add up to 180, well, those are same side interior angles. So if those are supplementary, that means that those lines have to be parallel. So L is parallel to M because same side interior angles are supplementary. Okay, and then lastly, in this one, I have 1 and 7. Again, we see that those are marked as congruent, so I can say because those are alternate interior angles, or sorry, alternate exterior angles, because those are congruent, we know those lines have to be parallel. So again, we're doing the opposite. So I see a pair of congruent angles or I see a pair of supplementary angles, and I use that information to determine whether the lines are congruent. Okay, so ways to prove that lines are parallel, we could have alternate interior angles, alternate exterior angles, or corresponding angles that are congruent. And then we could have same side exterior or same side interior angles that are supplementary. These are the only 5 ways to prove lines parallel. In the last section, we looked at linear pairs and vertical angles. However, those do not have to have parallel lines in order to be supplementary or congruent. So just because a linear pair is supplementary doesn't tell us anything about whether there are parallel lines. Okay, same with vertical angles. Just because vertical angles are congruent doesn't mean that we have parallel lines. Vertical angles always congruent in every situation. Linear pair always supplementary in every situation. These up here only happen when we have parallel lines. All right, so let's look at this. Again, here's some examples that we're going to figure out. So I have this angle is congruent to this angle. Okay, there's those marks there. So those are alternate interior angles. And because they're congruent, right, I can say a line blank is parallel to line blank. So again, I just have to figure out, here's my two parallel lines, and then here's my transversal. So for this, I would write M is parallel to N because alternate interior angles are congruent. Right? If I look at this next one, I have a congruent angle here, a congruent angle here, right? So again, this line, there's my two parallel lines. Here's my transversal. So I can say that M is parallel to N because alternate exterior angles are congruent. So I don't have any markings or any information to tell me whether those lines are parallel. It's a conclusion that I'm making because those angle pairs are congruent, and that's what's marked. Okay, so we can use that then to find a value of x. So it's saying what is the value of x for which A would be parallel to B. So we're going to assume that these are parallel, or sorry, we're not going to assume that they're parallel, but we want to figure out what this value would be, this value of x would be to make them parallel. So if I'm looking at this, these are same side interior angles, and so they have to be supplementary. So together these two need to add to 180. So I'm just going to say 2x plus 9 plus 111 equals 180. Because if these two are supplementary, then I can say that these lines are parallel, and that's what we want to prove. So combine your like terms. Subtract 120 from both sides. So 2x equals 60. So x is 30. Okay, so again, if I plug this in, that gives me 69 degrees, and if I add those two together, 111 plus 69 is 180, and so that means those two angles are supplementary, and so we know then we could say that A is parallel to B when x equals 30. This in. Okay, let's look at one more. So again, we're trying to identify the types of angles. So I have this angle here and this angle here. Those would be corresponding angles. And corresponding angles are congruent, right? So we want these two angles to be congruent. If they're congruent, then these lines are parallel. So we're going to solve for x, assuming that they're congruent, because again, that will make the lines parallel. So I'm just going to do x plus 25 equals 55. Solve for x. And again, x equals 30, right? So if I plug that in, that gives me 55, and that's 55. When those are parallel, or sorry, when those two angles are congruent, it means that L is parallel to M. Okay, so again, that's the goal. When x is 30, right, that's the value of x to make L parallel to M. Okay, so like I said, very similar to what we've done the last few sections. It's just the reverse way of looking at it, but the same properties apply. So going back to those three types of angles that are going to be congruent, corresponding, alternate interior, alternate exterior, and then same side interior, same side exterior are going to be supplementary. That's what we have to look for. The rest of this is some additional examples. Feel free to print and give them a try, and we will continue this in class tomorrow.